Hello everyone, this is Sainath from CSMC section. Today the video presentation is about pointers in C. Your gateway to memory management pointers are fundamental in pointers is nothing but fundamental C programming offering direct interaction with memory. Understanding them is crucial for writing efficient and powerful code. This presentation will guide you through the interactions of pointers from basic declarations to advanced concepts and best practices. Now we are discussing about what is meant by pointers. A memory address in disuse. Pointer is a variable that stores the memory address of another variable. Instead of holding direct value, it points to where that value is stored in the computer memory. This capability allows for direct memory manipulation, which is both powerful and requires careful handling. There are three types: direct memory access, efficiency, and flexible. Direct memory access pointers provides a way to directly interact with memory locations. Efficiency. They enable more efficient more uses and faster program execution, especially with large data structure. Flexibility. Pointers are key to dynamic memory allocation and working with data structures like linked lists and trees. Declaring and installing pointers. Getting started. Declaration. Declare a pointer with a risk before its name, including it will stores a memory address. The type of pointers must match the type of variable it will point to. Int ptr. Installation. Installation means assigning the address of variable to pointer using a address of operators. It is good practice to initialize pointers to avoid undefined behavior. For example, int num equals to 10, ptr equals to slash. Dereferencing. Access the value at the memory address stored in the pointer using dereference operators. This allows to read and modify the original variable. Printf %d, comma, slash ptr slash output is 10. Pointer arithmetic. Navigating memory blocks. Pointer arithmetic is a powerful feature that allows you to move pointers within memory. When you increment or decrement a pointer, it moves a size of the data type it points to, not a single byte. Incrementing ptr p incrementing plus plus moves the pointer to the next memory location of same data type. Decrementing ptr minus minus moves the pointer to previous memory location of the same data type. Addition ptr plus n moves the pointer n position forward. Subtraction means pointers which moves the backward. Difference means ptr1 minus ptr2 calculate the number of elements between two pointers of the same type. Important note: pointer arithmetic only meaningful when performed on pointers that point to elements within same array memory block. Pointers and array a close relationship. In C, array names are essential constant pointers to their first element. This inherent connection makes pointers indirectly useful for traveling and manipulation of arrays efficiently. Array name as pointer. An array name like arc can be used as slash arc theta. Accessing elements. Elements can accessed using pointer arithmetic. Efficient transversal. Points provide a fast way to iterate through array elements without recollecting the indicates. Pointers and functions passing by reference. There are two types: call by value, call by reference operators. Call by value. When argument are passed to call by, a copy actual argument while sent to the function. Changes inside the function it's not affect to original variable. Call by reference pointer. Passing through function allows the modify original variables. The function receives a memory address, enabling direct manipulation of the data at the address. When arguments are passed through, address will address to copy the actual argument. Dynamic memory allocation. There are four types: malloc, calloc, reloc, free. Malloc allocates a specified number of bytes from heap and returns a void pointer to the beginning of the allocate space. The allocated memory is unutilized. Calloc allocates a memory for a array of the elements and initializes all bytes in the allocated space to 0. It takes the number of elements and the size of each element. Relocase changes the size of previously allocated memory block. It can be expand string the memory. If expansion is not possible at the current location, it allocates a new memory and copies the old context. Last one is the free. Delocates the memory previously allocated by malloc or reloc releasing memory crucial proficient leaks. Pointers to pointers double pointers advanced concept. A pointers to pointer allow also known as double pointer handle is variable that stores the address and the other pointer. This concept is used in more complex memory management scenario, especially when you needly modify a pointer itself from the function. Syntax declared using two tricks. Use causes modifying a pointer within a function, memory for pointer inside the function, implementing multi-dimensional arrays, working with command lines arguments, understanding the double pointers, unlocking solutions to more interacting programming challenges, but also demands a deeper understanding of memory layout. Common pointers, pitfalls, how to avoid them. Dangling pointers, null pointers, memory leaks, wild pointers. First we will discussing about dangling pointers occurs when a pointer points the memory location has been delocated or avoid set pointers a null immediately after free memory. Second one is memory leaks. When dynamically allocated memory is no longer free, leading a gradual reduction in available memory. Avoid always pair. Third one is null pointers. Null pointers that not point any valid memory location differencing then leads segment fails. Avoid always check a point a null before declaring. Wild points. Unrelated pointers that contain garbage values pointing to orbiting memory location. Differencing them can be led to unpredictable available always installing pointers, even null if no address is implemented. Best practices and key take for using pointer efficiently. Initialize the pointers allows initialize the null they do not point to avoid the immediately the prevents while. Then check the null. Always check the if pointers is null before differentiating it. Avoid segments false. Pair malloc with free. For every malloc collect and relect ensure their corresponding free to prevent memory leaks. Understanding pointer types. Be mindful of data type and pointers points to especially during pointer arithmetics. Use constant correctly. Use constant with pointers to prevent accident modification either pointer itself data points. Simplify when possible. Avoid while powerful avoid overusing pointers when simpler solutions are available. Clarity of enter. So thank